Hi guys, Mr. Bennett here. I want to ask you the question is, what happens if you can't easily factorise the equation? Now, you either might suck at factorising, or it might be, in fact, the equation that doesn't factorise very easily. Now, there's a few options that you can choose from. The first option, obviously, or probably the easiest option, would be to use the calculator. So let's have a go at a function that might not easily factorise. Let's go something like y equals x squared take 3x plus 7. Alright, so I don't think that's got easy factors because I know the factors are 7 and 1. Now, so the easiest thing to do here would be to go to your calculator. Now the first thing I could do is I could put that into my calculator and I could graph that. So I could go x squared take 3x. Alright, so just typing it as you see the equation plus 7, and then I graph that equation. Alright, so press graph. Now depending on what your scale is, whether you actually see the function there. Alright, so if you want to change a window, you simply go over here. Okay, so I graph my function over here, get a bit of an idea about what it actually does there. Now, in this particular case, it doesn't actually cut the x-axis. So when you're going to be looking at that, if you're trying to factorise that, it actually won't have any factors, all right? Because that's the factors are when y is equal to 0, and obviously y equals 0. That function is never y equals 0. All right, it looks like it cuts at 7 or something like that. Yeah, about 6 or 7. Sketching that thing, but we're trying to find the factors. Now that's one option, and then the other option you can do on your calculator is to do this. If you go to your app button, right, we come down to a thing called Polysim 2, so press number 4. Now we're looking to find the roots, the poly root finder, so this will find for the roots for quadratics and also for high polynomials. So press number 1. We've got a quadratic, so that's order 2. And we want to find any real roots, okay? We can also do imaginary roots. I'll just show you the difference of that in a second. So if I put my value in there, it's 1, it's going to be -3, so -3, and then 7, right? And enter. Then we just press solve over there, and it says I've got no real roots. Alright, now if I just go out of there, if I go back to my coefficients, I'll go back to my mode. Now I can actually do this for imaginary and real numbers. Alright, so if you do this spec maths, you'll actually see these things occur. Alright, again, if I press solve now, it'll actually give me two answers. Alright, so it'll actually give me an answer in terms of 1.5 plus 2.179 and 1.5 take 2.179. So we'll talk about what that means later, but you know, it can have solutions, but it's got no real solutions. Now generally in this year we'll only be looking at real solutions. Alright, so that's how you can use technology to actually find your things. Now there is another way of doing this which is actually quite neat. Alright, so we're going to use a thing called the quadratic formula. Okay, so I'll just write this down. So quadratic formula, and this is actually on your formula sheet. It's always given to you, and it says that the real values of x, the solutions of x, are going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this relates to a quadratic equation where you've got y equals ax squared plus bx plus c. So let's look at this equation for this function over here. Now there is a thing that we can actually do first to tell us and predict how many solutions we're going to get and what they're going to look like. This thing over here, I'm just shading in yellow, is a thing called the discriminant. Alright, it's got the symbol a little triangle, and that's equal to b squared minus 4ac, the bit that's inside the square root. Now you think about it, if that value there is equal to 0, then you've got minus b plus or minus 0, which really is just going to be minus b on 2a. So in other words, you've got one root. If it's going to be negative value, then you can't take the square root of a negative number. So therefore, it's going to have no real solutions. And if it has a value that's greater than 0, it's going to be minus b plus root, whatever, and it's going to be minus b, take the square root of that. All right, so the three solutions that we can have is the discriminant is less than 0, and then we say no real roots. And what that will look like is a case where the curve, right, doesn't cut the x-axis. All right, it could be like this as well. As long as it doesn't cut the x-axis, then it doesn't have any real roots. Again, this information's on your formula sheet. If the discriminant is equal to 0, then it has one repeated root. Right, so in other words, it's basically talking about it touching the x-axis. Alright, so that would be the case where my function comes down, touches the x-axis and goes back up again, either going down or going up, and so therefore it's got the one repeated root. So a repeated root means it's got to be a tangent at that point there. Now if the discriminant is in fact greater than 0, that means it's going to be, x is going to be equal to minus b plus the square root of that thing, the discriminant, and it's going to be minus b take the square root of the discriminant. So in other words, you have two, what we call distinct, so two different distinct real roots. So you've got two answers, right? Two intercept points. Alright, so that's what that means. Alright, so the first thing is, if you want to test before you do anything, if a quadratic has a real solution, and that's what we're solving for now, is if you did the discriminant here, right, it will tell you a little bit about what you've got. Now, a little trick here, what you might do for this is go a equals 1, b equals minus 3, c equals 7. Now I'm really only, I'm using all three. So I put my b in, so that's going to be equal to minus 3 squared, take 4 times by a, which is 1, times by c, which is 7. So that's going to give me, minus 3 squared is 9, negative 4 times minus negative 4 times 7 is negative 28, 28. So that's going to give me an answer of minus 19. Minus 19. Right? So therefore, no real roots. So don't actually have to do any more for that because I know it's got no real roots. Alright? Okay, that's what we're solving for. Let's just do another one just to show you if it actually does work. So let's say we've got y squared is equal to, not y squared, just y. So we've got y is equal to something like x squared, take, let's say something like 2x, take, let's make it take 3x, take 10. Alright, so that's a function. So again, we could write our a value. A value is 1, our b value is minus 3, our c value is minus 10. Minus 10. So therefore my discriminant is equal to b, which is going to be minus 3 squared, take 4 times by a, which is 1 times by c, which is minus 10. Alright, so that's going to give me 9. And then it's going to be negative 4 times negative 1 by 1 by negative 10, so it's going to be plus 40. So my discriminant's going to be equal to 49. So therefore, this is going to have two real roots. Alright, so it just means I can solve that for the actual roots themselves. So let's do the next part of this particular question. So now what I'm going to do is just put it into the formula. So x equals minus b, so minus minus 3 becomes 3, plus or minus the square root of the discriminant. Now the discriminant is in fact 49. I don't need to do any more because I've actually worked that out already. That bit inside the bracket. And then that's all over what value? Okay, that's all over 2a. What's 2 times by? So that's 2. Alright, so then what I'm going to get for the next line is I'm going to get 3 plus I'm on it. Now the square root of 49 is 7, and then it's all over 2. So what this means is my solutions for x are going to be the following. It's going to be equal to 3 plus 7 on 2, or it's going to be equal to 3 take 7 on 2. Alright, so that's going to give me 3 plus 7 is 10, divided by 2 is 5. So that's one solution, or 3 take 7 is minus 4, divided by 2 is negative 2. Alright, so they're my two solutions, so therefore my x-intercepts, or my roots for my equation, are going to be, in fact, x equal to 5 or negative 2. So, bottom lines, just to go back to the key points, the key point is, if you can factorise it the easy way, you do it that way. If you can't factorise it the easy way, you've got two techniques really. You've got your graphics calculator with 2 ways of doing it there, and you've also got your quadratic formula which you can use. Alright, the process is understanding what the discriminant does, the bit inside the square root, whether it's going to have a solution or no solution, or two real solutions. Alright, so obviously a bit of practice for you to actually learn how to use this formula, but once you've done that, most of these questions are pretty straightforward. Alright, the key thing that we're looking for is the answer, so we're looking to find out what the x-intercepts are in this particular case. Alright, so make sure you have a go at those questions. If you need some help, please make sure you catch up with one of us teachers.